Our paper is on understanding conceptual transfer for students learning new programming languages. Any successful computer science student learns how to learn new programming languages. We are therefore investigating how near-novices transfer from their first to second language as a starting point for this learning. There is little existing work in this area. We encourage you to see our paper for details. Our earlier work that was presented at ATCC has led us to the development of a model of programming language transfer for near-novices, which we are going to present now, along with 2 studies that help validate the model. At the heart of the model is a language learning mechanism that has been derived from natural language learning research. In summary, when a learner of a new language sees a word that looks similar as one in a language they know, they transfer the meaning in the old language across to their developing knowledge base of the new language. Sometimes this works, sometimes it doesn't. Consider the Norwegian to English example. When you see this Norwegian word finger, you might think it means finger in English, and you are correct. When you see this Norwegian word fyre, you might think it means fire in English, and you are wrong. It actually means fall. In our proposed model, the programmer's knowledge is built of a network of nodes that are connected at different levels. There is the syntax, the semantics, and concepts, following a connectionist approach of cognitive learning. When a programmer is learning their first programming language, association between the nodes are established. Each route running from conceptual level down to syntax level represents a concept, its semantics, and its representation in the syntax of that language. At the prior knowledge level, where students know just one language, there is no branching across the semantics or syntax levels, because for a given concept, there is just one implementation and syntax known to the learner. Once students learn the second programming language, more interesting knowledge structures are developed. Concepts D, E, and F all represent important but different kinds of ideal relationships between concepts found in 2 languages in a programmer's mental representation. These concept relationships are presented in the next slides. A true carryover concept. It's a construct with similar syntax and same underlying semantics in programming language 1 and 2. For example, a while loop in Python and Java. The correct relationship between languages of a TCC in a programmer's knowledge structure should show no branching from concept to semantics and syntax because the 2 languages share similar syntax and semantics. But what actually happens when a learner encounters a TCC during learning a new language? They will perceive it as a TCC because of syntax match. Hence, semantic transfer will be appropriately effected from programming language 1 to 2, and the learning will be positively impacted. A false carryover concept. It's a construct with similar syntax but different semantics in programming language 1 and 2. For example, equality of arrays in Python and Java. In Python, it compares array values, while in Java, it tests whether the 2 arrays have the same memory address. The correct relationship between languages of the FCC in a programmer's knowledge structure should show branching from concept to semantic level, because the 2 languages share similar syntax but different semantics. But what actually happens when a learner encounters an FCC during learning? We predict that if a learner encounters FCC, they will perceive it as a TCC because of syntax match. Hence, semantic transfer will be inappropriately effected from programming language 1 to 2. This does not match the correct learning above. Learning will be negatively impacted. An abstract true carryover concept. This is a construct with different syntax but same semantics in programming language 1 and 2. Examples are constructs whose implementation details are hidden, such as data abstraction objects in Java, which at a low level are data structures like Python dictionaries. The correct relationship between languages of an ATCC in a programmer's knowledge structure should show branching from semantic to syntax level, because the two languages share similar semantics and concepts but different syntax. But what actually happens when a learner encounters an ATCC during learning a new language? We predict if a learner encounters an ATCC, they will perceive it as a novel concept, since there is little or no syntax match. Hence, there will be little or no semantic transfer, which does not match the correct learning above. Now that we have explained the model of programming language transfer, we are now going to present two studies which aim to validate the model. These are in the form of Programming Language 1 test and Programming Language 2 test, taken when students are learning a second language. We propose three hypotheses. Hypothesis 1. There will be no significant difference in the score for concepts involving TCC between Programming Language 1 and 2. Hypothesis 2. There will be a significant difference in the score for concepts involving FCC between Programming Language 1 and 2, such that Programming Language 2 score will be less than Programming Language 1 score. Hypothesis 3. There will be significant difference in the score for concepts involving ATCC between Programming Language 1 and 2, such that Programming Language 2 score will be less than Programming Language 1 score. In Study 1, 70 students who had learned an average of 1 year Python participated. These students were transitioning to Java. Once they had learned some Java in week 3, they took a quiz in both Python and Java, testing the same concepts. Each concept category was marked out of 4. A Wilcoxon-Sandberg test was used to measure the significant difference in the languages. The results showed that for a true carryover concept, both Python and Java scores were high. There was no significant difference on individual constructs between Python and Java as predicted in Hypothesis 1. For the false carryover concept, the Java scores were significantly lower than the Python scores as predicted in Hypothesis 2. And finally, for the abstract true carryover concept, the Java scores were significantly lower than the Python scores as predicted in Hypothesis 3. In order to further validate the model, Study 2 was a reverse transfer, this time around from Java to Python. 33 students participated. They all had an average of 5 months Java prior knowledge. They were given a test in Java and Python in week 6 of learning Python. The results of Study 2 show that both the Python and the Java scores for the true carryover concept were high. There were no significant differences on individual constructs between Python and Java as predicted in Hypothesis 1. For the false carryover concept, both Python and Java scores were lower than the TCC and the ATCC. There were significant differences between the Python and the Java construct scores, but this time around semantic transfer was happening in both directions, from language 1 to language 2 and from language 2 to language 1. For the abstract true carryover concept, both Python and Java scores were lower than the TCC. There were significant differences between the Python and the Java construct scores only on the object aliasing construct. As predicted in Hypothesis 1, students were seen to be breezing through true carryover constructs such as the while loop, if conditional functions in either direction, from Python to Java in Study 1 and from Java to Python in Study 2. This is because they were the easiest to transfer, because the syntax looks similar and the semantics are the same, hence no change is required in the existing knowledge structure. For the false carryover construct, as predicted in Hypothesis 2, Study 1 construct scores were all significantly lower for the Java as compared to Python. However, In Study 2, the semantic transfer was happening in both directions, from Java to Python and from Python to Java, such that the construct score was negatively affected in both languages for different constructs. This could be because the construct is more intuitive in Python than Java, or the students had their first encounter with the construct in Python language instead of Java language. And lastly, it could be because the students' prior knowledge of the construct was still fragile because they only had 5 months of Java knowledge, hence susceptible to change, as compared to Study 1 participants who had 1 year Python knowledge. But the most important thing to note is that regardless of which direction the transfer is coming from, students still held one semantic model of 2 languages. They seemed to struggle with having 2 semantic representations of a single concept, as elaborated in the model. For the abstract true carryover concept, as predicted in Hypothesis 3, Study 1 construct scores were all significantly lower for the Java language as compared to the Python language. Contrary to Hypothesis 3, we did not find a significant difference in the score except for the object aliasing concept in Study 2. Participants did not seem to struggle with the ATCC constructs in lists and dictionaries. These results imply that participants found it easier to transfer their knowledge of ATCC from a language that has an abstract representation like Java array lists to a concrete representation like Python lists. What's next for us? We believe that this model can be used as a basis to explain the learning processes involved in language transfer in the classroom. In our future studies, we hope to find teaching methods that can guide teachers who teach new programming languages. I would encourage you to read the full paper that has more details and examples on these issues of transfer as well as the study materials. Thank you for listening to this talk.